Practice Exam 1, Version D. Pause the video while you read the question. According to the law of constant composition, all samples of a given compound have the same proportions of the constituent elements by computing the ratios of the masses of each element in all sample. When computing these ratios, it is most convenient to put the larger number in the numerator and the smaller one in the denominator. In this problem, we know that the first sample containing carbon and hydrogen weighs 7.4 grams, and the second sample, which also contains carbon and hydrogen, weighs 24 grams. We want to find out how many grams of hydrogen is in sample 2. As you can see, we have two unknowns at the moment since we do not know how many grams of hydrogen are in the two samples. What we do know is that there is specifically 6.2 grams of carbon within sample 1. Therefore, we can calculate the mass of hydrogen in sample 1 simply by subtracting 6.2 grams of carbon from 7.4 grams. As a result, we then get 1.2 grams of hydrogen, and that is how many grams of hydrogen in sample 1. We still do not know how many grams of hydrogen is in sample 2, but we can solve that algebraically by cross-multiplying, and I'm going to represent the mass of hydrogen in sample 2 as x. So we get 7.4 times x, 24 times 1.2. And when we isolate x, with the help of the calculator, we get x equals 3.9 grams of hydrogen. Once again, remember that x is the mass of hydrogen that we are trying to find in sample 2. So the answer is choice A. There is 3.9 grams of hydrogen in the total mass of sample 2. Now, to double check if the law of constant composition was applied, we look at the mass ratios. In the first sample, there is a 6.2 to 1 ratio, and in the second sample, it is also 6.2 to 1 ratio. Since the ratios are the same for the two samples, these results are consistent with the law of constant composition. In other words, it does not matter how much of this compound we have. A certain set fraction of the mass will always be due to the hydrogen in this sample.